In this short demo, we're going to show you how to turn Kaggle's Telco Churn competition into a Kubeflow pipeline using the Kale JupyterLab extension. Okay, we're going to start by making some assumptions. We're going to assume that you've worked through the previous demo, which means that you already have Kubeflow deployed. In this case, I have Kubeflow up and running via Aricto's Kubeflow as a service, and that you have a notebook deployed. And here we're going to be looking for 2 CPUs, 2 gigs of RAM, as well as 5 gigs of storage. And we're also going to assume that, like in the previous demo, you've already git cloned the Kubeflow/examples repository. So with those assumptions done, we're ready to go ahead and connect to our notebook. This is going to bring up our JupyterLab UI. And then from the UI, you can see we have our Kubeflow/examples directory. Navigate into it, then locate the Telco customer churn directory. And here we're going to have the necessary files that we're going to need to run our pipeline. One of the interesting files here you may want to inspect is going to be our data file. So if you're interested in looking to see what that CSV looks like, here's a quick preview. Okay, navigating back up into the Telco directory, let's go ahead and open up the Kale specific notebook. And the first thing that we're going to want to do with this particular notebook is go ahead and install our necessary packages. And we're going to do this via a requirements.txt file. You can see the contents of that requirements.txt file there. So let's go ahead and run that particular cell. And once we get confirmation that that has been completed, we are ready to enable the Kale JupyterLab extension. And with that, you can see that our notebook is already annotated. But before we get started, let's go ahead and restart that notebook. And our first cell group is going to be an import section. Here we're going to use the imports Kale annotation to denote that. Next, we'll go to our first pipeline step, and we're using the pipeline step annotation for this particular step, which is our load data step. Our next cell group is going to be a pipeline step, and it's going to be called transform data, and we're going to specify that it depends on the load data step. Next up is feature engineering. So here we're going to use, again, the pipeline step annotation. We're going to name it feature engineering, and we're going to specify that it depends on the previous transform data step. Our next step that we want to set up here is going to be one of 3 modeling steps. This one's going to be our cat boost modeling step, and we're going to signify that it depends on the feature engineering step. Our next modeling step is going to be the XGBoost modeling step, and you can see that we're going to indicate that it depends on the feature engineering step as well. Our next modeling step is going to be the light GBM modeling step, and you can see we're going to use the pipeline step annotation, and we're also going to specify that it depends on the feature engineering step. And that takes us to our final step in the pipeline, which is going to be the ensembling step. Here again, we're going to be using the pipeline step annotation, and we're going to show that it depends on the previous 3 modeling steps. And with that, we are ready to compile and run. So we're going to validate the notebook, take a snapshot, compile the notebook, upload the pipeline, and now the pipeline is running. So let's click on the view hyperlink, and this takes us directly into the runtime execution graph where we can see our pipeline execute in real time. You can see our volume has been created. We've loaded data, transformed our data, moved into the feature engineering step, and now our 3 modeling steps are executing. And once those modeling steps complete, we move on to our final step, which is the ensembling step. And from here, we can actually click into any of these pipeline steps and get more information about inputs, outputs, details, log information, events, as well as artifacts. So here we're going to look at the visualizations tab, and if we scroll down, we can actually see our confusion matrix that we specified in that particular step. And that's it. You have successfully created a pipeline for Kaggle's Telco Churn competition using the open source Kale JupyterLab extension.